This will be a demo session for a few of you, and um, introductory session for a few of you. So I was saying that from today we are going to start the ACI class. So today I will not go much deep dive. This will be introductory class so that people who are interested to enroll for the ACI, and for them today is a demo class. They can take decisions and they can join our this weekend to weekend course actually. So this course will be the delivery mode will be a weekend and online. So every weekend we will join around 11 a.m. and then based on our comfort, maybe a 1 hour or 2 hours. Like if you are new to the ACI and you feel that we should go slow, or if you are a bit familiar with the ACI, a regular pace is okay for you, then we can go in that mode. So basically, we will touch the nerve of the audience, and based on that, we can put the pace like a bit fast or slow or like that, or much emphasis on the some of the things and like that. So first of all, this is the netminion.net. This is our portal. And if you want to have a look on the course content, so the those guys who already join our demo session, they are aware. But for those who are new to this, let me give you a walkthrough on the where to find the contents which are going to deliver during this weekend class. Not going much to detail because few people are already aware, so I will respect their time as well. So let me go to the trainings. So this is the in the top tab, you will go to the trainings. You can go to the training, networking, and go to the Cisco, then data center, then you click on the ACI. Why we have put the ACI in the data center category? Because ACI is a data center fabric, guys. This is one of the important fundamentals I wanted to tell you, that many of the people are confused. So ACI is not something which you deploy at the branch locations or which you deploy at the campus networking. This is purely data center fabric. Okay, so it is always deployed at the data center level and it facilitates the application deployment. So that's why we put the ACI in the data center category, and you can see the Nexus is also there. So traditionally, we started with the Catalyst 6500 switches, 4500 the distribution layer, 6500 at the core layer, and then 3750 those days the 3750 were there, 2960 were there. That those switches we used at the access layer. Maybe we stack 3750 and then we increase the port density, but that is a different story. But those time it was. Then we moved to the Nexus, Nexus 7K, 5K, and 2K, where 7K act as a core, 5K as a distribution, and 2K is a fax, a remote card kind of thing actually. Then from 2015, uh, um, we moved to the ACI. ACI was introduced in the market in 2015, but it's got its speed in from the 2016 actually. So then we moved to the ACI. ACI is purely a leaf and spine fabric. So we will discuss more about that. But let's go to the let's see what are the contents around the ACI which we will be covering in our class. So this is basically covering Nexus 9000 series switches actually. So we have Nexus 9K switches, 9300 and 9500. Those you can configure in a NX OX mode as well as the ACI mode. But since this class is for the ACI, so we will cover how we can implement ACI on Cisco Nexus 9000 series switches actually. But options is there, flavors are both available. You can put Nexus 9K switches as a traditional way, I mean your core and distribution like that, or you can put in the ACI mode. But if you are spending so much on the hardware, so obviously you will go for the ACI mode and you can make the application deployment, you can facilitate the application deployment. So obviously, in the ACI is application-centric infrastructure. You might be aware. If you're not aware, yes, it's application-centric infrastructure. Why it's application-centric infrastructure? Because traditionally, we as a network engineer, we talk about the VLAN, we talk about the subnets, we talk about the routing, okay, switching, like that. If I add one few keywords more, but now in the ACI, you will talk about the EPG. You will talk about the policies. You will talk about the application profile. So those components, although you are not aware, but just using these terms as of now, so those are basically those components actually help in deploying the application in fast way. Because early days we talk about the networking component, application team talk about the three tier of the application, that is a web layer, app layer, and database layer. So there is no correlation between these two towers, which is network and the application team. But you will see that in ACI we will talk the application language actually. So we will see that in more details. So so this is just introduction and emphasis on that we are going to cover Cisco Nexus 9000 series in the ACI mode. Requirement is I'm expecting that you guys have bit understanding on how Ethernet switching happens, like what is ARP, what is broadcast, what is multicast, what is unknown unicast, and how switches learn the MAC address. Introduction or a bit familiar, if you are a bit familiar with the virtualization, that will help in one of the chapter where we will talk about the integration of the APIC with the VMware. And the data center architecture, obviously, like if you are aware about the data center architecture, it help you. But if you are not, no problem, you can call me, I will explain that topic in more detail. So not a problem. Exactly, if you are aware about, maybe you are from the ISP background, you are not from the enterprise networking, that will work. Not a problem. I will cover the basics. I will start from the scratch. So, and what you will learn. So what is your expectation? This section is going to talk about that. So you will get a thorough understanding on how we are deploying 9000 switch switches in the ACI mode. What is fabric? First of all, we will discuss, then deployment of the ACI fabric, implementation of the ACI management, all the inbound and out of band configurations. Then discuss about the connectivity, layer 2, layer 3 connectivity, and integration of the legacy towards the ACI, how we can integrate the legacy network if we have already and we newly deployed the ACI. So how we can integrate these two components, that we will talk much on that. Because you going onwards, when you get some project in the ACI or you are deploying ACI for the first time, so you will face this challenge. So those production experience I will share with you. A different migration option with the ACI. Obviously, your layer 2 is outside the ACI, or and layer 3 is in ACI, or maybe layer 3 is in outside network, and ACI is only supporting as a layer 2. So those scenarios we will cover. So this is the course content, and yes, a touch base on the programming. I'm not going to deep dive into the programming, but yes, touch base on the programmability and the orchestration part also I will cover, so that you should be fundamental, like how we can program the certain policy, certain contents. We can push the configuration via REST API integration and all. So that thing. And this is the detailed of the above contents, like overview, packet flow, logical constructs, virtualization fundamentals, talking about the hardware part and all. Okay, so you can go to the netminion.net and trainings and the networking and the data center and ACI, and you can browse these contents, have a look on that. Okay, and whatever the contents is listed there, we are going to cover that. So don't worry, we will cover in depth. And as a bonus, I will also cover in the last, during my last class, I will give you the introduction on the ACI multi-pod and multi-site as well. Not much on that because those are advanced course, but this is also going to be advanced course, because this is not, I'm just going to give you a overview, but more deep dive with respect to the configurations which we used in our day-to-day production life actually. Not in terms of just I'm going to give you a training and you finish the training, and but you are not aware how really we can troubleshoot the issues day to day in the production environment, how really we can implement if there is a ask from the management to implement certain configurations. Okay, so but multi-pod and multi-site, just maybe you few of you guys are having fundamental on the ACI, so maybe interested like whether NetMinion is going to cover on the ACI multi-pod and multi-site. So multi-pod, multi-site introductory sessions I will explain you, so that you can have also a fair idea about what is multi-pod and what is multi-site actually. All our lab course and workbook is based on the version 4. So and our lab is also based on that version, so you have to practice on that version. Okay, any addition plus minus we will see. So maybe anyway we have Cisco has not launched the version 5 so far as I know, but if any guy is aware and he is working on that, so we can discuss that if there is any addition in that. But this is currently in at least 2 3 project I have seen, people are running version 4 or maybe last trail of the version 3. So basically the configuration is same, no major change from the version 3 to version 4 actually. So those about, and that is about the ACI lab and all. So if you have any question regarding the content, you can ask right now. Otherwise, I can move to the introductory class. Today, I'm not going to do much deep dive, but yes, I will talk about what is ACI, why we bring ACI, and fundamentals of the ACI, difference between the legacy and the ACI networking. And then maybe from tomorrow onwards, we will go deep dive into this. Guys, any question on the contents?
Chitranjan is asking for the lab. Okay, so if you can just show him the lab, that would be helpful maybe for Chitranjan and rest of the people who joined today. So should I share my screen?
Yes, please go ahead.
Okay, please.
Yeah. Many guys are interested to know.
Yeah,
Yes. I'm
yeah,
sorry, I overlooked that part.
it's all right. Please stop your sharing screen so that I can share. Okay.
Absolutely. Oh, stop sharing. Yes. Go ahead.
Okay, guys, do let me know if my screen is visible to you. So, is it visible to everyone?
Yeah.
Yes, it is visible.
Yes, yes.
Okay, thank you. So this lab you will get, okay, the one who would be getting enrolled for our this course, you will get this kind of lab. Okay, how to access this lab, that is the separate thing that we will be covering maybe later on. Okay, and then once you are there, just log in into this management PC. Once you have the management PC access, okay, these are the controller IP, then whatever the username and password is, just open it from your Chrome, because this management PC has the LAN access over the Epic. So just I am putting out the IP over here, 192.168.0.112, and it has the username and password of admin and NetMinion, which you can change as per your choice. Okay, maybe I am already in. Okay, Manish, maybe from the technical perspective, you can please go ahead, and if you want to
Yes.
explain about something, you can please take the lead.
Yes. Thanks, Nitin. Okay. So, guys, we have this Epic. You can see this is the dashboard of the Epic. Okay. We have this um, two leaf and one spine and one epic, because this is a lab environment. So everybody will get the pod. I mean, every individual who will enroll for our class will get one separate pod. So that means if let me call out any name. Let's say if Avinas is doing some lab configurations in his pod, so Pratik will not able to interfere in that. So Pratik will have its own pod, Avinas will have its own pod. So whenever you get time, you access the lab and you complete the job. So all the major configurations are, what we say, yeah, deployments or configurations or the policy, I will cover in the class. And at the same time, I will ask you to access your pod and complete and show me where you are facing the challenge, so that your problem can be sought out at the same time. It's not like that I'm giving you the homework, or I am saying that guys, okay, I'm going ahead and you will do later on, and then it's become later on only. You did not completed the lab, because in ACI lab part is very much important. So in NetMinion we focus on lab as well as the concept equally actually. So it's not like that I will be running throughout the PPT and I am done with the training and it's done. No, not like that. It will be kind of partnership. So all the major lab, I'm going to repeat again, all the major labs I will show you. First, I will show you how to do that, how to achieve that configuration, how to achieve the ask. If management is saying, let's say a very simple example, I'm telling you, let's say management is saying, Avinash, you have this two Nutanix server. Okay. You have this two Nutanix server, P11 and P112. You have to connect that server. You have to configure the vMotion interface. You have configured the data port in ACI. Okay, how you will approach this? This maybe sound very simple. Particularly if you talk about the traditional networking, it's very simple. There is a one management switches there. They used to connect the server port into that, and there you simply configure the VLAN maybe in layer 2, and then you for data port you go to the 6500 on Nexus. You configure those data ports, whatever the VLANs is required actually, right? But in ACI it's a bit tricky actually. Okay, in ACI the configuration is defined in terms of the policy. So you should understand, you should have a concrete based on the policy, how policy work. Okay, so that's why the major portions I will cover in the lab. I will give you the demo. At the same time I ask you to access your lab. At the same time I'll ask you to access your lab and complete the job. Then small configuration, small lab we will do, or you have to do in the background maybe whenever you get time. So there will be dedicated lab, so don't worry about the lab. That is the one thing. Just give me 1 minute, let me have a sip of water.
So Chitranjan, may I have answered your question over here? Is it okay for the lab you were asking, right?
Yeah, okay. So yeah, so I was saying, so that is the mode we will do for the lab. So everybody will log into the management PC and log into the Epic. You will land on this dashboard. You can see this is the Epic application policy infrastructure controller, and you can go to the tenants, you can go to the fabric, virtual networking, L4, L7 services, and in the sub menu you can see the quick start, dashboard, controllers, and all. So we will go step by step, slowly and slowly, into all these steps, and we can see how we can leverage them to achieve the configuration, guys. So any question regarding the lab? The Paint, and I will not use any PPT. I will use the Paint to draw the diagram and deliver the content. So let's go over to the Paint and share my screen. Okay. So ACI is application policy infrastructure. So just I am saying application policy infra or infrastructure, that is flow. Let me write down complete. Maybe few of you will say that. So ACI is application policy infrastructure. Okay. Why application? I mean, this is networking, right? We have a leaf, we have spine switches. I mean, 9500 switches and 9300 switches. These are networking component. Many of you will think, why this name is application policy infrastructure controller? So let me give you the background. Okay. So the application team talks about, or with respect to the application, forget about the application team. With respect to the application, we have a three tier: web, app, and DB. Web servers are front-end servers. Then web servers talk to the application servers to get the application contents, and all the database are stored in the database server. So front-end servers are the web server. When you connect, let's say you say netminion.net. So netminion.net will first hit the web server, then the web server will talk to the application layer will talk about DB. So that's why application team talk about these terms actually. But what we talk about the VLAN, we talk about the subnet, we talk about the routing. Okay, so there was a huge gap between these two entity actually. So let's say application team is saying that I have to deploy the web server. So for you, it does not matter what they are going to deploy. You will ask them, hey, can you give me which VLAN you want this server to put in? Okay. So for you, does not matter with a web server or app server or database server. You just need to know which VLAN they want to connect in. Then maybe you will go to the switch and log in and map those interfaces with the corresponding VLAN or the required VLANs and all. And if you are configuring the new VLAN, so obviously you will get the subnet. First, you will decide the subnet based on the zone, and then you configure the SVIs, VLAN, and then you do the routing. And when you map the VLAN, you will say that, okay, yeah, I'm done. But maybe the application team is not aware about the VLAN and the subnet, because for them it is similarly like for you it's no matter what is the server, it is for them it's no matter what is the subnet and routing and all. So then sometimes you ask them to give them a reference of the server, then they will say, okay, this is the reference server, you can configure all the attributes or configuration according to that. Now, how the ACI solve this problem? Because generally what happened initially when there was no corresponding between the application and the network layer, so it takes a long to deploy application actually. And it is the application that brings revenue to the customer. So we build infrastructure because we have to run the application on the top of that infrastructure. If you are building an infrastructure that does not support the application, indirectly it means it is not supporting the revenue. So it is always a try of a network team or network layer to deploy the application in a way so that it can facilitate the application deployment. Now, in ACI, how it is solve the problem? They introduce one entity. So don't worry much about the terminology EPG and all. I will explain in detail, but just I'm covering the introduction, so I bring this term. So they introduce one entity which is known as a EPG, which is known as a EPG, endpoints group. And these endpoint groups may be or can be classified as a different thing based on the requirement. So let's say with respect to the application layer, I can create one EPG and I will say web EPG. Then I will corresponding to the application, app layer, I will say app underscore EPG. Then corresponding to the DB, I will say DB underscore EPG. Now, this web EPG, this web EPG may have servers from 10.1.2.1, 10.1.3.1, 10.1.4.1. So now here you can see the difference is, it was not like that where you were defining the web with respect to the VLAN and the subnet. It is based on the attribute. And what is the attribute here? Web, HTTP or HTTPS, right? Most of the applications are like this only. So my EPG, this web EPG, when I'm creating on the ACI, this web EPG does not matter what is the subnet it is holding. It is holding 10.1.2, 3, and 4. You can mind the third octet. So now EPG is a thing which does not depend upon the VLAN or the subnet. Okay. Can you mute? Yes, sorry. Thanks. So earlier, what we used to do, we classify the things. We classify, let's say, web server. I mean, in networking, traditional networking, we put the web server maybe in VLAN 2, application server in VLAN 3, database server in application in 4. And we configure 10.1.2.1 the gateway for the web, and 10.1.3.1 the gateway for the app, 10.1.4.1 for the TV. So if application team is rolling out the database server, we put the database server in this 10.1.4.0/24 subnet, app in 3, web in 10.1.2.0/24 subnet. Okay, but here in the ACI we talks in terms of the application layer, application tier. So we create, what we will do, we will create 3 EPG, web EPG, app EPG, and database EPG. And these guys don't mind whatever the subnet. So one of my web server can be in 10.1.2.1, another of my server may be in 10.1.3.1. So it does not matter. Now in the, let's see the, let's say this is my app tier. So I will create one app EPG, and here maybe one server is in 10.1.2.2 and another server is in the 10.1.6, or let's say 8.1, no problem. Now you can see the app is also holding a IP of this subnet 10.1.2.1. This is my app. Now you can say, okay, this is app and this is a web, and these server are in same subnet, so they will talk. No, in ACI it is not like that. In ACI, EPG can talk to another EPG only when there is a contract in between. So we have to define a contract. It does not matter. It does not matter that these subnets, these are in same subnet. 10.1.2.2, one app server and one web server are in same subnet, but still they will not able to communicate until you define a contract. So you will define a contract, and you will define that from web to app. Let's say for HTTP, you have to define HTTP or HTTPS or HTTPS or 8080, whatever the ports application team required from the web to the app. I mean, this is just introduction. We will talk more on that. We will see. So here, what is the point I wanted to bring out to you is, here subnet is not boundary. So here subnet is not boundary. Here the grouping, the EPGs are defined on based on the attributes. And we will see how we can define that EPG, how we can define that policy, and how we can make it working. So that's why ACI is named as a application policy infrastructure, because it don't support the traditional way. I mean, support that. There is a two flavor actually. We'll talk more on that. But Why application policy infrastructure? Because here it majorly support the application tier, which is web app and DP. Here the grouping is not based on the subnet, which is a VLAN. Here the grouping is based on the attributes, which is based on the application tier. So I hope this point is clear to you. Okay, so that's why its name is application policy infrastructure. And what is policy then? Okay, we came to know that, okay, this is the why it is named as application policy infrastructure, because here the configuration will be based on the application tier. It don't mind the subnet boundary or VLAN. I mean, the grouping is based on the uh, app, web app or DB tier, not based on the VLAN, subnet and routing. Now what is policy? So okay, policies, let's
Hello.
say, yeah.
So, yeah, if you told that under the YVPG we can match the different type of subnet like tender 1.2, tender 1.3, and tender 1.4.
Correct.
So, let's an example. My server team is going to introduce a new server,
Uh-huh.
and they choose the subnet as per their convenience. Okay,
Mm-hmm.
and they just told me the IPs.
Mm-hmm.
So how I can, on which attribute basis I can call that IP of that server to the YVPG?
No. So no, let them configure whatever the IP they are going to put. Okay, let them configure. What you will do is, you the EPG which you have already, you what you will ask, your question will be, this is a web or app or DB. Okay, this is the web or app or DB. They will say this is a web server. I mean, this much information they will give you. Not like that. The
Yes, sure.
request.
They
Yeah.
will give that it is this is
Yeah.
your website.
Yeah, they will give that information. Actually, when the ticket will be routed to you, that ticket will having this basic information. So don't worry about that. So when they will say, this is a web server, I'm going to, I wanted to web server to communicate, or in other words, please onboard the web server into the network, like that. Actually, you will get that ticket. Now, if you are building the infrastructure first time, so you will define like that. Okay, but if the infra is already in place and you join this project recently maybe, so you will go to the ACI, will log into the ACI dashboard, and you will go to the EPG and see what is the EPG is there. Okay, so you will see, I mean, different organization has a different naming convention, so I don't want to comment on that, but you will get to know about that, which is the EPG for the web server, which is the EPG for the application server, which is the EPG for the database server. Then let's say this is my leaf. I'm not drawing the spine, guys, so don't confuse. Just to here I'm drawing. So this is my server. This is how it is physically connected, and then this web EPG you will deploy at this VPC interface which you create in the ACI. So first up, your task will be to create a policy for the physical connectivity. So you remember I said that here the configuration is known as a policy. So I was coming to this point, but you asked this question, so I'm telling you. So here the configuration is the policy actually. In ACI, we call policy, we don't refer configurations, because configuration is tied to the hardware actually, but policy is not tied to anywhere. I will come to that point, you will understand more on that. So first we will define the VPC policy, and then we will map this web EPG to this VPC policy. Then this server will become a part of the web EPG. Similarly, we will configure for the app. Similarly, we will configure for the DB. But web is not allowed to talk to the app. App is not allowed to the DB until we create a contract. So application team will say that web EPG will talk to the app EPG. I mean, they will not say EPG because they don't know EPG, but they will say web will talk to the app on port 8080. Then you will define a contract with port 8080. So contract is at very high level, you can say ACL, but contract is more robust. if you compare, since we are introductory class, so I'm just saying ACL, but it is more robust than ACL. It has more capability actually.
That means you're trying to say that we need to be that will be a VPC, or we need to be create a new VPC for that web server, and you need to be go to that EPG and create a static port, right?
Ah, absolutely, absolutely, guy. Yeah.
Okay.
Hmm.
Like this, we have to call to the web EPC.
Yeah, VPC. If you don't configure VPC, see in ACI, for every connectivity, you have to define a policy actually. If it is a single interface connectivity, if it is a port channel, if it is a VPC, you have to first define, and then you have to map this EPG on the top of that policy. Then it will get applied at the hardware level.
Okay.
Okay.
Yeah, yes, sure. Thank you.
Sorry, I did not get your name. What's your name?
Santosh.
Santosh. So Santosh, are you working on any ACI environment as of now, or like
Yeah, I'm working.
hmm.
So, but in our infra, we have used specific subnet for OVPG and specific for app and DB. Okay,
So
so
yeah, I understand your point. So actually, ACI can be deployed in a two mode. One is
application centric and network infrastructure, right?
application centric and network centric mode. So in your organization, you have deployed in the network centric mode. So you have configured the ACI more like traditional network, where your for web you have one subnet, for app is another subnet, for DB another subnet, right? And you are putting all
Correct.
your web server in one subnet, app on one subnet, and DB in one subnet. That is also there. That is also there. So
Mhm.
many organization you will see that peoples are configuring network centric because we are comfortable more in doing that, right? We understand more on VLAN, subnet, and routing rather than the grouping of the endpoint based on the attribute, not on the subnet. In some organization, you will see people are using this application centric approach, and in many organization, you will see hybrid approach, that is network centric plus as a application centric. So for something, they are using the application centric mode, and and for some things they are using the network centric approach. So both are possible, but here I bring this point. Why? Because since you are aware, many guys are not aware. So I was explaining why we call it as application policy infrastructure. Because if you are grouping based on the VLAN and the subnet, then why you call it as application policy infrastructure, right? Anybody can ask this question from this audience itself, that still if you are doing the VLAN and subnet, then why it is application?
Mhm.
Correct. So that's why I
Correct.
explain why it is application policy infrastructure. But we will cover both scenarios in our lab, the application centric mode and network centric mode. Majority of the things we will do network centric mode, because 90% of the deployment people are using network centric approach. So that we will see. Let's not go detail because many people are new, they will be thinking like what is going on. Okay. So now, application policy infrastructure. Now you understand why we call it as a application policy infrastructure. And what is policy? So I was saying that if you are going to a club or any society or any place, and there is a sign of no parking, there is sign of no parking. What you will do? I mean, we Indians generally don't follow the policy. That is a separate thing. But let's say if you go to a place where there is a sign of no parking, or maybe they put that 500 will be imposed on the person who park his vehicle here, then obviously you will not park your vehicle there. So if you see this, what you will do? Okay, this area is prohibited for the parking, you will not park your vehicle there. So this is policy. This is a policy, because based on the configuration, based on the policy, the action has been taken. Similarly, in ACI, you will create the policy, and based on the policy, the action will be taken. So you create a policy which is also known as a intent, which is also known as a intent. I mean, what you want to do, that is your intent. Okay. So you have the hardware, you have the underlying Nexus 9K and 9300. 9K means 9300 and 9500 in terms of leaf and spine. Hardware is there. What do you want to achieve with that? What is your policy? What do you want? So that want is actually a policy in ACI, or in very layman term, you can say that is the configurations. So that is the meaning of policy. So basically, this infrastructure behave or work based on our intent or based on our policy. Like one example I have given you. So that's why it is application policy infrastructure, and why it is policy, because of this. Okay. So that was enough on the introduction part. So I mean, just the name part. So let's see how and what ACI brings on the plate. So I'm just going to draw one line. This is my ACI and this is my traditional. Because many people ask like why you bring, even in interviews they can ask you traditional network. Fine, everyone. So very first difference is your very first question difference is traditional network is core, distribution and access layer, and in ACI it is only two layer, spine and leaf. Now let's talk about this point. In traditional networking, we have three layer: core, distribution and access layer. Core is a backbone. It's high speed, resilient component of the network. Distribution is the layer where you create the policies, your SVIs, or your route map, your ACL. And access layer is where you hook up your servers, your access point, your laptops, right? So there is a three layer: core, distribution and access. But in ACI, we have only two layer: leaf and spine. And how, what makes it, but okay, so you will say that what is the big deal? Here it is a three layer, there is a two layer. No, it's make a difference. You see, this is my core, this is my distribution, and this is my access layer. Okay. Let's say you create your SVI at the core layer. Many times I have seen that. Okay. SVI is 10.1.2.1. Distribution they use only for distributing to the access layer. So 10.1.2.1, and we have also SVI up 10.1.3.1, and there is a one server in the same access layer switch. There's two server. This server is in the subnet 10.1.2. Let's say 20, and this server is 10.1.3.20. Now, if this guy 10.1.2.20 wants to talk to the 10.1.3.20, it has to go all the way long to the core layer. Here, the routing lookup will happen, and then it will come again to that access layer switch, and then the packet will be forwarded to the this server. And the challenge, what is the challenge there? The challenge is if you forget to create layer 2 VLAN, also mapping of VLAN on any of the uplink, then this communication is not going to happen. This communication is not going to happen. Let's say this is my uplink from the access layer to the distribution layer, and this layer you don't apply the VLAN. You missed to apply the VLAN. What will happen? Will the communication will happen? No. But in the leaf and spine architecture, in the leaf and spine architecture, in leaf and spine architecture or ACI, the gateway is not tied to any layer. It is seamless. It is a floating. So gateway is also available here. Gateway is also available here. And if you have 100 of the switches, it is available on all 100 of the switches. The 10.1.2.1 is no more tied to this hardware. It is seamless. It is floating across the leaf switches, and it is not like that the spine is holding the SVI. It is the leaf layer itself. So if there's a two server, and although they are in two different subnet, the lookup will happen just at this layer, and the packet will be routed. So you can see the forwarding is more efficient in the ACI compared to the traditional networking. Here, let's say compute guys do a V motion from this to this. You don't have to worry about that as a network administrator, because your gateway is floating. Your gateway is pervasive gateway. In ACI, it is known as a pervasive gateway. It is available across the leaf switch. So you don't have to worry about the subnet and all, because when you do a V motion, the gateway is available. It will communicate. But in traditional networking, if you are doing a V motion to some switch, if it is not connected to the same core layer, which is having the SVI, then you have to first create the SVI there. You do a kind of HSRP or VRRP kind of that, and then only you can do a V motion. And here you can see the packet is moving all the way to the this layer and then coming back. Although they are connected on the same access layer, same access switch. So this forwarding is not that efficient, guys. So that is one of the major difference. So here you can see the gateway was tight. So even if you are using a router and you go to the interface gig 00, IP address 10.1.2.1, subnet mask /24, no such. That 10.1.2.1 entity is tied to that interface, tied to that router. That is a challenge when you want to do a vMotion, that is, when you want to migrate the server from one to another point. Here, the gateway is no more tied to the leaf, any of the leaf switches. Even though it is 100 of the switches, it is available across the 100 of the switches. So it's all one of the major challenge. Second thing is, just let's forget about 3 tier. Let's say in our network only we have a 2 tier in the traditional networking. Okay, so this is our connectivity, maybe physical connectivity, and this is your connectivity, and maybe you have configure a VPC, peer link and all. If you have Nexus and all, even though you will configure Catalyst 95 6500, also you will configure the link between them. Now this is traditional, so your STP is working. STP is working. What is the job of STP? If you have redundant layer 2 link, if you have redundancy in switching, the STP will block one port and make one port as a blocking and one port as a forwarding to avoid the loop. So maybe this is forwarding and this is blocking. This is forwarding and this is blocking. Suppose that these are 10 gig ports. Okay, so this is my, these are my 10 gig ports. These are my 10 gig ports. These are my 10 gig ports. So come, you know how much we spend on for the 10 gig ports. They are expensive port, right? Even you purchase a router, not all ports are 10 gig ports because their network module is expensive. So although we are having, we spend so much, but one of my link is on the waiting mode, in blocking mode. Only one of the link is in forwarding. That means that 50% of the link is unutilized. 50% of the link is unutilized. So 50% of the link is my unutilized in case of traditional networking, but in ACI, let me draw a line between this difference, create a difference. So in my ACI, which is my leaf and spine architecture. So first thing is in ACI, the leaf will connect to the spine will connect to the leaf, no leaf will connect to each other. Okay, so no spine will connect to each other, no leaf will connect to each other. We'll talk more on the topology part, but right now I'm bringing the difference, so bear with me. So this is my particular or very traditional kind of deployment. Two spine and two leaf. Here you can see this leaf is connected to the spine 1 and spine 2. This is also connected to the spine 1 and spine 2. Okay, but no leaf is connected to each other, no spine is connected to each other. So here no leaf is connected to each other, no spine is connected to each other. That is one of the major difference. Second thing is these ports are routed ports. These ports are routed ports. So when the port is a routed port, then there is a no issue of layer 2 loops. Obviously you don't need a STP, or STP will not work on layer 3, right? So you don't have to worry about like one of my link will be in blocking, another link will be in the forwarding kind of thing. Your all link will be in forwarding state. So you are using what you are paying for. Now, let's say This is my spine 1, spine 2, leaf 1, leaf 2. Okay. And here on leaf 1 you connect a server, on leaf 2 you connect a server. S1, S2. S1 want to talk to the S2. What will happen behind the screen, behind the, I mean in the background, ACI will do some hashing algorithm, and it may select this interface. So the packet will, when arrive on the leaf 1, ACI may select this part. Let's say for this flow, it selected this interface. So it will go to the spine, and from the spine it will go to the leaf 2. Or let's say another time ACI select this interface. Okay. So even though the packet will go to the spine 2, come to the leaf 2. So in any scenarios, the destination is always one hop away. In any scenario, one hop away, whether it take this path and this part. So this is not per packet load balancing. ACI is per flow base actually. So for this flow, even ACI select this part, it will go like that. If it next time for another flow it select this part, it will come like this. So you can see for any path it will take, the destination is always one hop away. Okay. Second thing is, in ACI these uplinks support a speed of up to 100 Gbps. Okay, so 100 Gbps or 25 Gbps. Okay, so they are very high speed link actually, but most of the time, I mean in my 3 projects of the ACI I have seen the leaf and spine is connected via 100 Gbps. So this will be your 100 Gbps, this will be your 100 Gbps, this will be your 100 Gbps. So these are high speed connectivity. So the packet in the backbone, I mean, you even not think about how fast they travel when they hit the leaf and go to the another leaf actually. So now what I'm trying to say is, one thing is your destination is always one hop away, and your backbone is high speed 100 Gbps connectivity. So this cost is also 100 Gbps, this cost is also 100 Gbps. So that's why it is known as a ACI is ECMP, equal cost multipath routed fabric, because these ports are routed. We will see more detail how it routed, and in some scenario it can also work as a layer 2, but we will look into details. Let's not touch those points. This is very introductory class. So ECMP routed fabric. Why? Because this is a one hop away. Whether no matter how much path you will take, and every path is equal cost, like 100 Gbps 100 Gbps. So that's why it's ECMP routed fabric. So here you can see your both links are utilized. Okay, so that is the second major difference. Third is, okay, anybody's asking any question? Okay, no. Okay, third difference is, in traditional networking everything is allowed by default. So that's why it is known as a blacklist model. In ACI, everything is disallowed by default. That is why it is known as a whitelist model. So what happen? If you don't want a server to communicate to another server, and those are in two different subnet, you will configure a ACL and apply at the VLAN. Or so for tweaking some traffic at the routing layer, you may configure route map and all. So traditional networking is okay. Sorry. Let me give you one practical example. Let's say you are invited to a party. Okay. You are invited to a party. You got the invitation. You take your invitation in or invite card with you, and when you reach the venue, there is one security guard. A security guard will ask for your name or your invite card. It will look into that, and then it will check into the guest list. If you are into the guest list, he will allow you, otherwise he will not allow you. That is whitelist model. That means communication is purely based on if you have allowed that communication or not. So although your routing is perfect, it will not going to happen because at the data plane layer, the policy is not allowed. So the ACI as a whole don't allow any communication until unless you specifically mention that. So please mind that this is very powerful statement, and this is for any configuration. Let's say you are configuring L3 out, or you are configuring L2 out, you are configuring any transit routing between two L3 out or anything. Please mind that you will go and you will see the show IP route, and the route is available. Still the communication will not happen until you will not create a policy to allow that communication. But what happened in the blacklist model? So let's say you went to that party and there is no security guard there to check your invite. You go to the party inside. Although even though you are not invited, you went into that party and you create ruckus there. Actually, you create some nonsense there. So the next time people will say that, okay, this guy has created nonsense here. Let's not allow this person next time. So what will happen? They will mark you in the blacklist. So again, when you are going to that party again, they will not allow you. That is blacklist model. That is what we are doing in traditional networking. The communication which we don't want to happen, we block that. And rest of them is permit IP any. So I hope this makes clear what is blacklist model and what is whitelist. What is whitelist model, and ACI is a whitelist model, and traditional is a blacklist model. No, the other differences are in your traditional networking. If you want to create a segregation, you can create just a VRF, virtual routing and forwarding context. Let's say there's some partner and you have to enable the configuration on your routers, on your switches. So, and your corporate traffic is also there. What you will do most at? You will configure a VRF, you will say partner VRF, you will put those interfaces in the partner VRF. So those will be the, that is one way of doing a segregation. But in ACI, VRF is there, but you can create a tenant. You can create a tenant. So tenant is a logical container where you can put all your networking component inside that container. So let's say you have a three environment: prod, UAT, DMG. You can create a three container, and correspondingly you can inside that container. So see how much concrete, how much segregation you are getting entirely. And you can, so one tenant will be like your complete one network, one autonomous network. And you can also define RBAC, role based access control, like Avinash will be the admin of tenant one, Bridges will be admin of tenant two. So Bridges will not look into the tenant inside tenant one, what is happening, and obviously vice versa. Even though you can use overlapping IP addresses and many things, actually, it's very powerful things. So segregation is there. So till now, guys, do you have any questions to ask?
Yes, Manish. There is a question from Chitranjan Raut over the chat. I don't
Okay,
know.
over the chat.
Yeah,
Okay.
maybe if you replied or no.
Yeah. Okay. Let's.
He's
Okay.
ask, he is
I
asking about the L2 device connected to ACI, and that L2 device causes loop. Then what is the loop prevention mechanism in ACI?
Okay, good, very good question. Very good question, Chitranjan. Let's say, okay, so I'm going to just say what is your question so that everybody can hear once time more. If any L2 device connected to the ACI and that L2 device causes loop, then what is the loop prevention mechanism in the ACI? Okay, so let me take that scenario here and the new pen diagram. So I'm not drawing this spine layer just to save the space in the pen diagram. This is my, let's say this is my 2960 or layer 2 switch. Okay, and this switch is connected like this. So first of all, Chitranjan, there is a no physical connectivity between these two leaf layer. So 1 minute, let me write it here. Leaf 1 and leaf 2. So first of all, there is this connectivity is not supported. If by accident you even connect these two leaf together via a cable, then there is a protocol that is known as a MCP, miscabling configuration protocol, that put this interface into error disable state. So there will be no link between the two leaf 1 and loop 2, although you deliberately connected that. So you can see there is no closed loop with respect to the physical thing. That is one thing. Now, let's say, now I'm also drawing the spine layer here. Um, let's say this is my spine layer. Now let's talk about the logical connectivity, let's say. Okay, let's say there is a logical. Let's talk about logical connectivity, because physical connectivity anyway, this is not occurring as a closed loop. So there is no chance of the physical layer 2 loop. But it may happen that in VLAN 3, okay, both on the VLAN 3 and in ACI also, you are a network centric approach guy. So you created the configuration as a VLAN 3 in the ACI. So VLAN 3 is also available here in the whole of the fabric. Okay. What happen if the configuration in ACI is making this fabric, if the configuration in ACI is making this fabric as a layer 3, that means your BD, bridge domain, is enabled with unicast routing. So for VLAN 3, if you have enabled the unicast routing, then whatever the layer 2 packet will go here, that will be not propagated inside the fabric. So there will be no loop. There will be no layer 2 loop because your whole ACI fabric is acting as a routed fabric. So you cannot pass your layer 2 things over layer 3 particularly. That is the one thing. But let's say your BD is configured in a layer, your BD is configured in a layer 2 mode. Sorry, it's a layer 2 mode. So that means this unicast routing is not enabled. Oh, 1 minute. This unicast routing is not enabled. Then this fabric is acting as a layer 2. So whatever the packet, any STP packet, let's say your BPDUs and your STP regular packet, can transverse the fabric and come here. So there can be loop. So for that, there is one setting in the BD that you need to enable during the configuration. So that's why in ACI, this is bit advanced. Today's but just introductory class, but it's okay. You ask, no problem. So that's why the BD configuration layer 3 as well as the bridge domain configuration in the layer 2, you need to tweak certain configurations there that I will cover. So when you make your BD as a pure layer 2, then what are the things you should enable? And when you want your BD pure as a layer 3, then what are the things you need to enable? That we will discuss in detail in the further class. Okay. So if the fabric is acting as a layer 3, then there is no chance of STP loop, right? But when the fabric is acting as a layer 2, then we need to certain enable. So there is a one settings in the BD that will act as a per VLAN, and then there we need to tweak some settings so that it can block if any loop is there actually. So actually the ACI fabric itself don't support this STP thing, but it will not disallow any BPDUs or any topology change notifications. Actually it allow. So in that case, particularly in the layer 2, we have to tweak some test configuration so that the loop cannot occur. So fabric will act as a layer 3 as well as a layer 2 based on the configuration. That's why I said that it's a routed fabric, but in some scenario you can make it turn on and turn off as well. That is the beauty of the ACI fabric. So Chitranjan, I hope this answer your questions.
Yeah, thank you.
Yeah. Okay, guys. So I think we already 12:22. It's um, more than 1 hour and 20 minutes, maybe. Okay,
Yes,
Santosh. In
thanks. Thanks.
traditional, I think Santosh is asking in traditional
Okay.
Nexus switching when creating VPC in a peer key level, but in Asia there's no interval between different how will achieve. Yeah, Santosh, that is also again a very good question, guys. So those who are new. So in traditional networking, yes, let's say we have this Nexus 7K and 5K. So we used to configure keep alive link and peer link, but in ACI we don't configure that because the fabric itself acts as a peer link and peer keep alive link. So let's say there is a no keep alive link, peer link, but the packet will be the health traffic will pass through the fabric and go to the leaf 2. I mean, it will go as spine in the leaf 2, and they will come to know about each other that the other leaf is available actually. So in ACI, you don't need to configure peer link or keep alive link. The fabric itself acts as a keep alive link and peer link. So I hope this answer your question. We will talk this in more detail when we'll talk about the traffic flow. Then that will make you more understand.
Thank you, Manish, for the beautiful session. Please stop sharing your screen. Let me share
Okay,
it.
1 minute. Yeah, sure. Okay, pause, stops here. Yeah, I did.